I like that you let people who are sick also do that. That's so nice that we don't have to catch what other people have.
I don't want to catch it, especially not right now.
Mm-hmm.
I'm trying to not be super paranoid, but you know, I got to go to that website.
Right.
They're up to like 20,000 cases. So.
Right.
Okay, I'm going to send Madison a message. Okay. Okay. Madison, we have started our program before we started our Zoom session. And here's what we have so far. He can get it. He's really good. Okay, so we are now calling our display instructions method. And the next thing that we need to add then is a method that prompts for a string input. So I want to put this right after my display instructions method. If I kind of keep them in order, even if it's just my order, that'll help. So this is going to be another static method. And this time it's not going to be void. It's going to return a string. Now, in our hierarchy chart, we said we want this method called input string. And last time we saw that we could go ahead and return some sort of placeholder, but we're going to be so quick at coding this that we won't need to do that. So let's write out a prompt here, and you can ask them for their favorite song, favorite band, whatever. What is your favorite band? That's what I'm going to ask. And then I'm going to use a return statement and return whatever I read from the console. That'll be the end of our input string method. And when we put a call for that in our main, we're not really going to be able to tell much about whether it works or not. So let's just go ahead and write a little bit of our output method. So I'm going to put that right here where I am. And again, it's going to be static and void because our display output method isn't going to return any values. Now, one thing about our display output is it's probably going to need some parameters. So we'll come back and put those in. Well, I feel like I'm getting out of order. So I think I want to go back to the main and put in my call for the input string and all that kind of stuff. Feeling like I need to do more outlining, but it's okay. In our display output, the first parameter we're going to have is a string. And for me, this will be the band that they entered. Yours might be something different. In my display output method then, I'm just going to output your favorite band and then a parameter. And I want to replace the parameter with that band variable that's going to be passed to this method. So I was getting all worried before I was putting in that parameter thinking, well, wait, I don't know what I'm going to do in my main. What am I going to pass to this? And then I thought, wait, it doesn't matter what the main does because this method is completely separate. And so I can call that parameter whatever I want to. And it doesn't really matter what I do in the main. It matters what this method does because it stands alone. And that's what we want. Now for the display output method, let's put in some comments like we did I've got some extra curly braces. Sorry, let me get rid of those. Put in some comments for our method header again. So we know static. I'm going to try to make them say something different this time. Void, no return data type. Display output is the identifier. And finally, the reason that I wanted to put in these comments again is because this method has parameters, or at least one. So it has a parameter list. There's only one parameter in the list, but the parameter list is data type, then variable name. Bless you.
Thank you.
So you can see how things get to be a little bit long right away when we start using a lot of comments. But I want to add a call to my input string and my display output methods in my main. So I'm going to go back to my main to add that. Right now, all the main does is call display instructions. If I'm going to call my input string method, I'm going to need a string variable to hold what the user picks. For me, it was favorite band. So I'm going to declare a string called favorite band. When I declare a variable like this, a local variable that's declared within a method, it's only available to this method. So I can't see that fav band variable in any other methods. But I can see it in this one, and that's all I need right now. So whenever I call my input string method, I'm going to tell it to save the output into the fav band variable. And then I can use that fav band variable to call our output. Display output, right? So in our display output method, we're going to send it that favorite band variable. And when we get to our display output method, remember it's going to call that data band. It's not going to refer to it as the same name. That's okay, because they each stand alone. All we need to know is that we're sending a string or receiving a string. So each of these, if you notice, is handling things a little bit different. Do they seem different? They are, just a little bit. Display instructions doesn't take any input or output from the program. It only sends information to the console. It's sort of output, right? But it's not the kind of output we're talking about within the program. Next, our input string method doesn't require any input, but it does return a value as output. In our display output method, we do require some data to be passed to us as parameters so that we know what to output. Let's run it. Does it work? So far, so good. Okay, what's your favorite band? I'll do Green Day today. And I got output. Your favorite band is, and that's what you should see at this point. You should see your prompt for your string input, and then your output of your string. Stuck?
That's what I want. Sorry to interrupt. For some reason, mine's not. Doesn't like my read line, and I keep looking at it. I think I've spelled it and done the same as you. Yeah.
It's written correctly.
It's written the same way she has it on the screen and their screen, but
you gotta make sure you have the thing at the top, the using line that says.
Static system console.
Okay.
That's what it is. You got it. Woohoo. Good job. So everybody is working? Get them working. Don't be shy. Help each other.
So what do you mean?
Ah. Now, what is this one? Now, this one means that's Did you hear the fireworks and stuff last night? Did you see how the World Series stuff? Did you see fireworks last night? You didn't hear them? Did you hear them? From the Chiefs winning? They were crazy. I think there's more fireworks than ever in the Chiefs. I mean, if you're going to be in the United States, this is the place, right? Probably would have been better to be in Kansas City. It looked like their fireworks were crazy. Did you see, like, even the weather satellites saw their fireworks because there were so many in the atmosphere? You could see them on the radar. So, pretty cool. Is everybody else's working? We're going to save this. We're going to use it. All right. So we're in pretty good shape. We've requested our string. We've got it. We printed it out. She's like, we should stop there. No. I'm going to keep going. So now we're going to keep going. So we've got our string. We're outputting it. Now we need to write two more methods that accept numeric input. I'm going to go to the REPL because I know that we had a REPL that had that in it. So let me see if I can find it. So I'm going to try the student REPL thing here. Now, you guys have seen already today, there's a couple of reasons that I wanted you to do this, but one kind of side effect is, now you know why I worry so much about you guys getting code off the internet, right? Because if you go grab code off the internet and you can find from opening curly brace to closing curly brace and just compile it and get it to work, I'm going to recognize it. Other than that, you're going to have to get all those pieces to work together, and you're going to be doing just as much work practically as you coded it yourself anyways, right? Because you have to understand how all the pieces work together. And that's what we're looking at here in our program, is different pieces and making them all work together so that we can have multiple developers working together on a project. So we don't see the whole thing from beginning to end. Okay, so let's see. It was lesson 4. And I want to say it was this car price input methods. There it is. The input price one. So in our REPL, where it says add the method body, gives us the whole method body we need to input a decimal value. So I'm going to copy this. Now, if you haven't found it, you haven't found this REPL, that's okay, because I'm going to put it into Visual Studio and we'll all have time to get it written there. So don't worry about going and dragging it over from the REPL. But what I want you to see is that I'm not going to think that you did something wrong if you went and copied that code someplace else. So I want to put this input method after our input string. I know it's going to be static. And let's see, in our hierarchy chart, we want it to be input DEC. So I'll make this one return a decimal value and be named input DEC. And then I'm going to paste that code. Now I'm going to fix it up first before you guys copy it. And I'm going to change this to be something like, how much money do you have? And then I'm going to eliminate the parameter variable. Now let's look at this code here, because this is stuff that we haven't done yet. So far, we've talked about declaring variables in general and creating methods. And this week, we're going to talk about creating classes. So we're actually talking about like the foundations of your C# program, the structure of it, how to put things together. We haven't gotten into the logic statements like if statements and loops and things like that, right? Driving me crazy, but we're going to. Well, so this one gets into that a little bit. So we're going to write out our prompt, and then when we read, we're reading right here, this read line statement that's embedded within all this other code. We're reading in what they type. Well, we're reading that in and processing it immediately with a try parse statement. And what the try parse statement does is it takes that input and says, hey, can I parse or convert that input to a decimal? If it can, it places that decimal value into this temp variable, the output variable. If it can't convert it, because the user typed in letters or something like that that can't be converted to decimal, then it will put a 0 into that temp variable. Now, the way this is coded, it will just keep executing over and over until that user finally types in something that can be parsed as a decimal. And then we'll finally let them out of the loop. So within our while loop, we want this message, this prompt, to be pretty much the same as the prompt they received in the first place. So I want it to say, how much money do you have? So I'm going to copy that part, and I'm going to paste it down here to complete the rest of that line. So now I'm going to write out the message, how much money do you have? If they type in P, it's going to say invalid value, how much money do you have? If they type in Q, it's going to say invalid value, how much money do you have? And it will keep doing that until they type in a number. When they finally type in a number, that number will be in the temp variable and will return that value. And this is the end of our input DEC method. Now I want to copy this method and make it work for an integer. So kind of cruel of me to give you that in the REPL. But not too bad, because if I copy that, I'm going to change my method name to input int. Here where I declare my temp variable, I'm going to change it from decimal to int. Then where I do the try parse, I'm going to again change it from decimal to int. And then I need to change my return type. Why do you think I'm not getting an error on that? Normally, if we return something that is one data type,
they'll return the decimal.
exactly. It's going to take that integer and implicitly convert it for us if we left it like this And that's not what we want. We want our output to be an integer. So we're going to make that be an int also. Now, when you look at those two methods, notice how close they are. They're almost exactly the same. We just are using an integer data type and a decimal data type. That's the only difference. Now, we should change our prompts a little bit, though. For our integer, I think I'm going to ask how many songs do you want to download or something like that. And then I'm going to copy that to my prompt for when they mess up. Beautiful. So in those two methods then, we have a method that will input an integer and make sure it's a valid integer. And we have a method that will input a decimal and make sure that it's a valid decimal value. So we're in good shape. Let's go to our main then and call these two new methods. We need variables to hold that data that these methods are going to return, right? Because we're going to have an integer and we're going to have a decimal value. I want to show you how class level variables work. So instead of making these new variables local, let's move them and put them in our class. So our class level variables could be considered global variables. They're global to the class. So any method in our class can see them. We want an integer. That was going to be the number of songs. And then we want a decimal value that is going to be the amount of money that they have. So I need to put these in the right place. The first thing that I want the user to be prompt for is their favorite band. And then I want to ask them how many songs and how much money they have before I call my output method, because I need to get that input from them before I can output it. So I'm going to put these calls right after the call to input string. So first, let's call our input decimal method. And that's going to be our amount of money. I don't think I have a typo. What kind of error message do we have for that? Mine's different. Mine's different. You have a typo. If I put the word decimal in front of it, I would be declaring it again as a local one. So I wouldn't be using the global one. I would be using the local one. So that would work. Why would that work? Because what's it? Yeah, and it wants it to be static, just like these methods that we call. Yeah, so I'll just put that keyword static where I declare that variable. And I'm going to have to do that for both of them. And I promise in just, a few more minutes, it's going to make more sense. Okay, so now it's not giving me an error anymore. It's all right. It's like, okay, you got that fixed. Now I'm going to put one more thing in. I want to call our input int method. So that one's going to return to us the number of songs. And we've already marked it static, so no error messages. So now the only thing I need to do is update our display output to output those new data items. So I'm going to go find that output. Okay, instead of just one right line, I'm going to add some more. You would like to buy how many songs? And how many is going to be a parameter, and it is in our num songs variable. Remember, that's a global variable, so I can see it. Now, if I tried to use the variable that we used in our main, our fav band variable, in that same way, I'd get an error because it can't, that is not a global variable. It's local only to our main, so I cannot access it. But I can our num songs because we declared it within the class outside of any methods. You have cash on hand. Wasn't there a way that we could make this amount of money display formatted as money? Can you remember what that was?
That where it's like the 0, the C.
Yes, very good. Colon C, perfect. Formatted as cash. Try it. Should all be working. So I should get my nice prompt for my message. Let's see, I have 4,000. Make sure and enter some decimal places because we went to all that trouble to make this a decimal variable. I want 3 songs downloaded. So now I'm getting all of my correct answers. Everything looks good. I've got my prompts the way I want them. It seems like I have some weird extra lines. So a couple of questions. In the REPL code that I copied, I see these backslash n's at the beginning of the write statement. What are those doing?
Making a separate one.
So that backslash n is exactly the same in any programming language. That new line character, that control code, is still backslash n. It was the backslash n in Python, and it's backslash n in C# and Java. So it just means go to a new line. So we're using write statements, and we're controlling when we go to a new line completely manually in that one, instead of letting the write line statement control it for us. What else? We've seen some new things here. We see this while loop that we're not going to get in too much, but the try parse is super useful for us to check if something's numeric. All of our calls look good. Everything's all happy. Now, when we look at our main method and it's doing all of these calls, remember that that's where they start saying that you don't want too much in one method. So we're in good shape right now. We're still way under a page because we have a lot of comments, but we'd want to kind of watch things. Okay, is everybody's working? All set? Because we're going to come back and look at this one again next week. Or maybe next time. Sure. So where you want? Up, up. That one? While everybody's getting caught up, Logan created or revised the Discord server for us, take a look here. When you're on the OTC CIS Discord server with the eagle up here, you can tell what server you're on over there. Why'd it go all crazy? And we have a new one. So if you go on the OTC CIS server to our private class Discord 15102, you'll see the invite to our new specific C# Discord server. And then when you do that, what are you doing, you silly thing? You'll see it's that blue icon. Oh, I have a keyboard, that's why it's being such a jerk. So you'll see the separate server icons over here in your server list. So it's really easy to jump back and forth. It's not like it makes a lot of extra overhead or anything. Now, in the C# channel, the reason we wanted a separate one is because there are several channels all set up for your study groups and different things like that. So when you get on this server, if you'll go to the bot commands channel, you'll see a whole bunch of bot commands already entered where people are joining their study group. And once you join your study group, then you'll have security to see the other components of the server. So if you join and don't join a study group, it won't really do you much good. Now, the in-class programs link is where we'll be saving things like, oh, I'm looking at 101. We haven't gotten there yet for that class. Be saving things like our code for the day or a PowerPoint that wasn't on Canvas and all of those kinds of things. Because I know it's hard to find everything. So we'll try to just always put it in one place. And Logan has it organized, you know, like I said, so it's a lot easier to find things. So in-class programs and different chats and things like that. So if you think of a category that you think would be super helpful, let one of us know, because I think that this layout works pretty well for us. And I like it. I feel like we could almost, if we got a Discord server configured right, we could almost replace Canvas with it, because then I can put things out there a lot easier. So it would be very nice, actually. Maybe we could get Logan working on that, and he can make his fame and fortune by replacing Canvas. He's like, over there choking. All right, beautiful. So since you've got access to that Discord channel, I'm going to close out of Visual Studio, and I'm going to look at this presentation that we posted out there. And make sure to not remove the OTC CIS one, because you want to still be able to get like that job postings thing and stuff, all that great thing. Welcome, welcome. Okay. Do you find your notes? We're kind of backwards. I would rather be doing this at the beginning of the class and having you guys do the program in the lab time. I've gotten a little backwards, so we're going to be working on getting it switched back around, I promise. Right now, though, we're messed up. So encapsulation is a big keyword that's important in object-oriented programming. And sometimes it's kind of nice to step back and say, what does this word mean outside of programming? It doesn't really have anything to do with programming. What is encapsulation? Well, here's something that's been encapsulated. This is like an anniversary gift or something, you know, for working for 10 years. So in this picture here, we have some earth and some grass stuff that's been encapsulated in this acrylic block to keep it forever, right? It's been encapsulated. What about down here? Down here I have a printout, and I have those sticky laminating sheets. Have you ever seen those? You have to do it wrong, you got to start over. Well, when we're done, if they do it right, this piece of paper will be encapsulated within those laminating sheets, right? It's stuck in there forever. Here's the best encapsulation. When we're looking at a smartphone, it has all sorts of circuitry and electronics and batteries and things, and they're all encapsulated within our phone. So you don't have to know, about all of those pieces of hardware and how to put that phone together in order to use it. They're all hidden, they're encapsulated, they're hidden inside of it. And that's what we want to do with our code. So in our program, we encapsulated some code. We said that how to input a decimal is something that our input decimal method knows how to do. We don't need to know how to do it anyplace else, right? Because it knows how to do it. We could just call that method anytime we need to input a decimal. We can maybe make it a little bit more dynamic, but it would be able to do it for us. So encapsulation is the process of taking code and kind of hiding it from others, making it to where they don't need to be super worried about what's going on there. Now in this presentation, there's some additional, instructions, reminders about the opening and closing curly braces and some of the things that we looked at last week, just to keep reminding you. Remember, our method name is normally uppercase in C#, and to call the method, we just put the method's name. But what am I talking about with encapsulation? Well, encapsulation, I'm black boxing something. So I had this story, and some of the people that were in my 120 class might have heard it. I can't remember. Sometimes I tell it, sometimes I don't. But I had this friend that worked at Conoco. I worked at Conoco, and it's an oil company, right? And when we worked there, they gave her an assignment to figure out how to create an algorithm that would determine how much oil or gas or jet fuel or whatever was left in a storage tank. And if you look at a storage tank on the side of the highway as you're driving around, just look like a big white thing. You figure they're really scientific, right? No, they're not. Their sides are like not very reliable, and they can kind of bow out, and they can weave in and get all sorts of weird shapes. They also have to put like an internal lid on the product. So if they have jet fuel or something in there, they have to have that fuel covered because it can't come in contact with the air or it would be explosive, right? So they might have like a big metal circular thing that sits on top of that jet fuel that keeps going down as the fuel level goes down. So Jennifer worked with all these engineers, and they gave her all sorts of different calculations and formulas. And they said, tank J97 or whatever has a weird bend, and so we lose this much volume because of such and such. And so she ended up with all of these crazy formulas and all this wild stuff for calculating exactly how much product is in a storage tank. Really important algorithm for someone like Conoco, right? Well, so now that she had created all that code, it's black boxed, right? Nobody else has to ever go through all that process of working with all those engineers. It's like working with engineers day after day. So nobody else has to ever do that again because she's gotten it all done. Now they might revisit it at some point, reevaluate it, but it's in a black box now. So if you want to find out how much product is in a given tank, your inputs are going to be like the tank specifications and the level that it was measured at, and then your output would be the amount of product that's in that tank. So by black boxing that code, that algorithm, now anybody can use it. Nobody else has to go through all of that trauma of trying to figure all that out. So that's what encapsulation is, and that's what we want to do when we're coding. We don't want to reinvent the wheel. Sometimes we might have a better wheel, so in that case we can maybe modify the wheel, but we usually don't want to reinvent it. Okay, so here is how a method is encapsulated. First of all, if we want input into a method, we set up parameters. Parameters can come from outside, and they come into our method. Also, if we want output from a method, we set up return values, and those would be output from our method. Otherwise, everything's hidden, encapsulated within our method. So the input, the output, and then our private data fields that we might create, private methods, all of those things are hidden or encapsulated. So we don't have to worry about what's going on. We can just use those methods. Now, why do we call things static or mark things as static? If something's marked static, it only occurs one time. The reason that we would call the main method static is because the main method is interacting with the console. The console, by its very nature, means it's only one, right? So if we think about an old PC, it had one monitor, that was the console. So a console was always the one thing that the computer operator is looking at. So we can read data from it, write data out to it, but there's only one, there's only that one console, so it became a static type device. We can only run it at one time, one place. We'll think of some others like that too. Now, another thing that we haven't used a lot are access modifiers. Public, private, those access modifiers would come before that static keyword. We don't need to worry about them right now because everything that we're creating is going to be private, and that's the default. So if you see an access modifier, public or private, on that method definition, it doesn't really have any impact to us right now. Private is our default. Public means that I could call that method from some other code in another solution, another application. Private means I can only call that code from within the same class. So they're very, very different. Protected and internal are somewhere in between, and we'll learn a lot more about those as they become relevant. Okay, we saw how we could pass a parameter and our return value. And if we have multiple parameters, our whole parameter list is going to be separated by commas, but we're always going to specify the data type and variable name for every parameter. We saw last week that we could have overloaded methods, that every method has a signature, and when we call our method, C# in the runtime, look at our call and see how our call matches up with a specific signature of that method to know which version of the method to call. In your textbook, they have some good examples of overloading some methods and the rest of that chapter 3 information. Remember that signature is comprised of the return type of the method, the name, and the parameter list. Okay, so encapsulation is important because it hides the details from other people. It lets our methods act like black boxes that they can just do things. Now, methods implement our modular code, right? So each method has a specific logical function, and we're working to make our code reusable. So when we created that application, we were working with that in mind. So before we go, what we're going to be starting on with encapsulation is object-oriented programming. So right now, let's see if I could get this to work. We've been looking at everything in a static way, right? So if I look at this sphere emitter here, this little purple thing is static, right? There's only one of them. So no matter how many spheres are emitted and active on the screen, the purple thing is still static, right? There's only one of them. It's the only thing that's emitting spheres. So it's static. But the spheres, on the other hand, they're completely different. They're very dynamic. Each sphere is an instance of a sphere. So when we have an instance of something, we have one occurrence of it, right? So if I look at my sphere here, each instance of this sphere had to be based on some sort of model, right? How do I generate a sphere? Oh, I got this model, it tells me how, and that's what I need to know. So if I'm looking at these spheres, tell me, what is one data element that my sphere model might be concerned with? What's something about a sphere that might be different for another sphere? Color, that's a good one. Anything else?
Velocity.
Oh, there's some. I didn't hear the other one. What else?
Radius.
But radius? They're all the same size, but that doesn't mean they have to be, right? And they're changing. What else?
What about how many times it's represented? I don't know how to say that in like a.
And you know, that would be something that we would have to do is more of an action. Because we would have to count them all to see how many yellows there were. So hang on to that thought.
It looks like they start at different places.
Starting location.
Yeah, they're pointing in different directions randomly. It's like,
Orientation, is that what you mean?
well,
Yeah.
I don't know if
Or
it's really-
direction.
Yeah.
Let's do direction, because any of those are probably valid. Anything else back there? Can you guys think of anything that's a data element that we need to know about all these? All of the physics stuff, of course, comes into play with it. So we could keep track of all of the different things. I like it when it goes that way. I know that's when everybody starts really watching it. Okay, so all of these things, I would also like to know, should I know if it has collided with something? Doesn't that seem to matter? Doesn't it seem kind of makes it bounce off? So I'll say that's a state thing, that it has collided with something, and we could come up with so many more. So all of these things could be thought of as data that's associated with each sphere, or attributes of each sphere, or properties. All of these are relevant to our object-oriented programming. So whenever I look at an instance of something, it has properties, it has data, but it also has behaviors. So what kind of behaviors would we have? We talked about one. I guess the first one I'm going to put is my instantiate behavior. Because to instantiate means to create an instance of. So that's my most important behavior, right? Because that's my birth, my sphere came to be. Now, what do we want to call your behavior? I'm one of how many? Or is that a good way? Because I mean, that might be really important. I'm one of how many? That could be a really relevant behavior to return to others. What if we wanted to just get the color? Get color might be a really important behavior that we would have for those spheres. Would we want to be able to set the color then too, to change it? If we wanted to, that would be a behavior. There's another one, destroy, which is what this application never does with any of them, sort of just keeps getting slower and slower and slower because there's spheres out there. Getting super thick. Yep, so they're getting very, very thick out there. So that's what we're going to start on next time, is looking at object-oriented programming. How do we create instances of things and control them programmatically, and instead of running in a static environment where we're only concerned about one single threaded item. So it is a lot different, a different way of approaching things. So in your textbook, chapter 5 begins talking about object-oriented programming. And at the beginning of the chapter, they have some nice examples using a car, some different things. So get started reading on that. And next time, we will look at creating our own objects using classes in C#. The REPL for this week is a class, so you probably don't want to start on it until after next time. But if that's already something that you're familiar with, go ahead and do it. It's just up to you. Okay, questions? Any? No? Glad you guys have it all. I'm going to stop it. That's it for today. Get started on your reading. Since I didn't let you have any lab time, let me know if you need any help with the REPL that's due tomorrow night. I think you guys all pretty much have it done, but I haven't looked at the details, so if you don't, that's fine. Let me know if you need help, but that is all we've got for today. Okay, so you need, if you need me to move it.
I was just hesitant because I was 11, so I just wanted to make sure.
Yeah, it's really useful those days. I don't know if the last time I touched days, but
I just wanted to make sure. Oh, yeah, no, I know.
do you know what he did? Do you know where he got something bad?
I don't know what happened.
Because it shouldn't have been
But-
IntelliJ stuff, you know.
I don't know what happened,
He
but
probably went off to some weird site for some JDK or something, I think.
you pretty much, yeah, possibly.
Uh-huh.
What I'm afraid of is like, because the way the IntelliJ video does it, you have to download the SDK for Java text
Mhm.
and then access
Well, and see, that's what I'm really worried about. Because, like, let me show you.
It's a little complicated at first, but once you kind of get it, then you
Well,
like.
what I'm worried about is that I felt like I have nothing to base this on. I felt like I shouldn't have to do that, but like that OpenJDK included it, everything I could find, the one that I downloaded.
The
anyways, it said
1.8
it was-
does, yeah. What I found out.
No, this is that OpenJDK, the 13.
Oh yeah, see that's what I use to get
Is
mine
it?
working. Yeah, the way I had to do it though is I had to download the
So you still
SDK
did
for
that
the Java
on
FX. I had to
Well,
download
what
a
I
completely different.
I
company.
downloaded